Okay, let me continue for our chapter 12. So in this slide, the visual sensor used for 2D surrounding awareness are monochrome camera. So let's say they are one color one, so the special reference one. So that is the optical device with one lens, which is a light-sensitive electronic array to form the image. And this sensitive array differ according to the band of electromagnetic spectrum. So they are sensitive too. So for navigation and obstacle detection, most of the camera incorporate array adapt to the visible spectrum. So that is about 400 to 750 nanometer, and in terms of the wavelength, of course, and often extend to the NIR band. Okay, so that extend to 700 to 1400 nanometer. So here, this image, this picture is showing about the structure of a camera. So you can see the light is going from this direction, and they will enter by through the lens and go to a mirror. So here is a mirror, and this mirror can be controlled, of course, and with a shutter here. You see, and this shutter will let the light pass through and hit the photo size sensor, so as to form a image in the data in electronical signal, and therefore they can go to your memory to save as an image one. And of course, at the same time, you are using this mirror or penta prime by looking using your eyes this way. So for precision agriculture application, multiple stripes of the electromagnetic spectrum are used based on the specific property being measured in the field. They normally range from the ultraviolet to the thermal infrared. And multiple spectral camera, in addition, are capable of capture various images simultaneously through the same lens by integrating different sensor arrays set up to sense at a particular electromagnetic band, allowing a pixel-to-pixel correspondence. Okay, so the second paragraph saying about a multispectral one, and here this image is showing about the light, which is a white light, and we call a polychromic light. And this polychromic one can be separated by a prime. So here we call is a triple prime, okay, or with a color filter one. So you can see the light beam enter in here, and they will be separated into three different directions. One to the sensor of red light, the second one is sensor of green, and the last one is the sensor for blue light. By this way, we can get a multiple spectral one. So 1, 2, 3, three spectra. And these three spectra, of course, they are corresponding to a particular electronic band. Okay, and each band have a different energy, and this energy can correspond to a different components or molecule for your crop or for your agricultural product. So here are the image figure of 12.2, the sensor position and image type for 2D visual perception of a vehicle vicinity. Okay, so from a top position, and you can see here should be the camera, and the driver is here, right? And we can take a sample image like this one. So maybe along the car, you can take the image, okay? And here is the front position. So this way is the front position, just on the head of your the tractor, and you can take the image like this way. Okay, so you can see that each row along the row, the fruit are growing like this way. Okay, and the third one is the side position, and you will see maybe using a platform like this way, and you can take an image by this way. Okay, yeah. So by different position, then we can take a different view on the crop, and later on we will join this information together. Okay. So for the 12.3 is a three-dimensional awareness for navigation and a 3D mapping. Okay, so 3D dimension basically have two approach. One is using 2D camera, and the other is using we call 3D camera one. And for a 2D camera one, basically we need at least two camera for this 2D. So we call a binocular. So you can see here is the name, is the term, binocular stereo image. Okay, so we have a, let me using the right hand side image to explain this one. So you have a left hand camera right here and a right hand camera. So generally this camera are same. I mean the same is the same model. Okay, yeah, for your convenient to calculate some parameter one, and they have a distance called b. That means that between this left camera and the right camera, and they also have a focus length called f. Okay, and here is the plane of the image, the left hand one and the right hand one. So if you have an object, for instance, the p is your object, they will project in your left hand camera on the UL position and to the UR position for this right hand camera one. Okay, so that is the basic physical geometry explanation. And if we go more detail, you can see the left hand side one. So the distance b we call a baseline. Okay, and here is the center of the we call left hand camera, and here is the center of the right hand camera, and he form a left hand image and right hand image on both this camera, and object is here. So the point project to each camera is different. Okay, by using this geometry, we can get the tips. Actually, we want to measure the tips is the most important thing is the third dimension. Okay, not only width and height, first and second dimension. That is the tips for this binocular camera try to solve. Okay, try to achieve to measure the tips of z. Z is the tips. That means how far away for this object to our base plane. Okay, yeah. And the other term is called disparity. That means they are different. For instance, your p point, the same object, project on the in here is the right hand camera. Okay, the right hand camera one, and here distance called xr, and xt to the left hand camera one, and their difference you see here, xr subtract xt is the disparity. Okay, so that is the term, and using this equation, and we can calculate the z. Okay, and of course before using this system, calibration always is an important issue. Okay, so once you know the basic theory of that one, then we jump to the camera when they were installed in the tractor. And in this tractor, you can see for this image one, he say the coordinate system and the transformation. A is for ground coordinate. So this one is the ground coordinate. So maybe he have a reference center point is here, OG, and each point, for instance, you have a crop here, and the position is for X, Y, and Z. That's to the ground point, ground coordinate. Okay, and we want to transform from camera coordinate to a ground coordinate because your camera information must corresponding or consistent to the ground position. Okay, so here is your camera coordinate. This one is your camera, and your ground is here. Okay, so they need you get the information from your crop or by your camera. That is a coordinate based on the camera one. But we need to shift camera coordinate to ground coordinate so as to get their information would be uh, consistent one by one. Okay, yeah. So the transformation from camera coordinate to the ground coordinate. Okay, that is the basic idea of this one. And here saying the equation of transformation. Okay, so you have the camera coordinate. For instance, here xc, yc, and the zc. So that's saying about this p point of your crop, your object, and that's based on the camera coordinate one. So you can see here is that your coordinate on the camera xc, yc, and zc. But we need to transform them, right? Transform to the ground. So you see here that is the ground. So we need to understand what will be their exactly value for this coordinate based on ground coordinate x, y, and z. So using this equation, and we can get their coordinate based to the ground coordinate. Okay. So equation 12.2 provide a mathematical expression to carry out a coordinate transformation, where x, y, z are the ground coordinates xc, yc, and zc represent the original camera coordinate delivered by the correlation software. So y is the inclination angle of the camera, and hc is the camera height measured vertically above the ground. So you can see here that is the height of the camera, and y is the angle, the inclination of the camera. So we back to here, so you can see y is this one, the angle, and the z, hc, I'm sorry, hc is here, is your camera installed on your tractor or somewhere, right? Okay, so I stop in here.